Okay, so tomorrow is our first test, Chapter 5. I wanted to just devote today to answer any questions and also address a little change. Initially, I had intended to set up Proctorio for you guys to take it, including that software, but I had a few technical issues and time issues, so we're not going to do that anymore. It's going to be a much more simple, streamlined process, and let me walk you through it. So let me see, let me share my screen. Okay, so starting tomorrow, you'll be able to log in to ConferZoom. I'm sorry, not Confer, to your Canvas account. So log in to your Canvas account like normal. And then right down here where it says modules, right here, it says modules. Select that guy, and well, you should already see this, but in fact, this should not be active right now. Anyway, you'll see something that looks like this, and you'll be able to click on the here, and then you'll see this. And so these are instructions for the exam, so you can read through them. This little thing here where it says, this thing where it says insert here, instead of saying insert here, it'll say Math 150 test number 1 or something. It'll be a live link that you can select and download a PDF version of your test. So you just select it from there, download it onto your own computer. Once you download it onto your own computer, if you want to print it, you can. You're allowed to do that, but it's not required and not recommended. I want you to do your own work on your own piece of paper. This is just so that you can, this is just a method for me to deliver the questions to you. Okay, so just work through it on your own piece of paper. Number 1, write out your work, show all the details, and then work on it on your own piece of paper. When you're done, you're going to convert those pages into a PDF file. If you have access to like a Word document, a document scanner or something, then you can use that to convert it into a PDF file. Otherwise, you can use a smartphone to do that, and I would recommend Genius Scan. It's a free app, and it does a really nice job of converting pictures through your phone into a PDF file. And then when you're done with all that, then follow these instructions. I want you to email the pictures to here, just Gmail. This is sort of a backup just in case something goes wrong. But the primary way in which I will receive your test will be to go back to this modules thing, and then you click here, submit here, and it'll allow you to upload the document through there. So there'll be a little thing for you to upload a document in here. Okay, the instructions on it give me a little fail-safe backup in case something goes wrong, because for some people the process of converting the pictures to a PDF gets corrupted or something, and then I don't really get your work. So just as a little backup, you can email me pictures, like actual pictures of your exam, your work, to this Gmail account. Do not send them to my school email account because the school server is very, very small. It fills up super quick. And also, each individual email is limited quite a bit. So you really wouldn't be able to attach too many things to an email that goes to the school email address. So don't do that. But this Gmail account should be okay. So you can attach the pictures of your work. Make sure you label the subject of the email with your full name, and Math 150 Test 1, for example, would be nice. And then send me the pictures to this Gmail account as a backup. But the primary way will be for you to convert it to a PDF file and then submit it over there where it says document, go back to modules, and right here where it says test 1, submit here. So the test begins tomorrow, Tuesday, September 22nd at 11 a.m. And you have 24 hours to complete it and submit it. So it needs to be uploaded before 11 a.m. on Wednesday, September 23rd. Okay, so you have 24 hours to complete it. The exam should take about 2 hours or so to do, so find some window of time where you can do it. Okay, I'd like to emphasize that this is an individual exam. You're only supposed to take it by yourself. You can't cooperate with anybody. You can't share your work or your questions or your answers or anything with anyone. I'm just relying on you to act responsibly and not cheat. Okay? If I suspect cheating, I mean it's pretty easy to spot when people cheat because inevitably you're bound to get something wrong, and if two people submit the same identical wrong answer, it really is a hint that people are cooperating and copying off each other and stuff. So, if two people cheat and they submit perfectly good, correct answers, it's hard for me to spot it, right? Both people knew the answer, okay. But when something is wrong, it's easy to spot. If I suspect cheating, then I'm going to void the test, and those people have to take a new test with me individually so that I can confirm that they really do know what they're doing. Okay? Any questions so far on anything? No questions? Are there any questions on Chapter 5 stuff? I don't really want to cover new material at this point since I know you guys must be working really hard to prepare for this test, so I don't want to overload you with new stuff. So I just wanted to spend this meeting time making sure that you know how you're going to take your test and answer any lingering questions about that, as well as any questions on Chapter 5 at all. Anything from the homework or the quiz, anything from the book, anything you're confused about, or anything at all that I can help you with to prepare for this test.
We get one chance to take the quiz, correct?
No, you get an unlimited number of times, an infinite number of times. So the homework, as you're doing your homework, you answer individual questions, right? So number one, number two. When you get one of the homework questions wrong, it allows you to redo that one question again, right? There's a little button at this bottom that says similar question. You redo it, and if you get it correct the second or third time, or however many times, eventually you get the credit for that one question, right? So on the homework, you get to redo individual questions. On the quiz, you don't get to do individual questions. You'll be assigned a random sampling of between 5 to 10 questions from the whole chapter. You submit your answers to all of the questions, and then you hit the submit quiz, right? So that kind of electronically submits the entire thing, grades the entire thing, and then gives you a score for the entire quiz. If you're happy with that score, then that's fine. If not, you can again choose to retake the quiz. So you cannot redo individual questions, but you get to redo the entire quiz. The difference being, aside from having to do the whole thing, that when you hit similar questions on the homework, it's going to give you a new question that's very similar to the old one. It just kind of moves around some of the numbers. Whereas on the quiz, when you hit to submit, or you select to submit, you select to take a new quiz, it will randomly select a brand new sampling of questions. So it won't be just that some numbers get moved around. It's a brand new set of questions that are given to you. So again, you completely do that quiz, and when you're done, you hit submit. And then again, if you're happy with your score, you can keep it. If not, you can retake the whole quiz. So you can retake the whole quiz in an unlimited, infinite number of times and just keep the best score possible. Okay. The only restriction to that is the deadline for the quiz, which is on Course Compass on your account. It says the due date or the deadline. For the quiz, that's a hard deadline. You cannot work on it past that deadline. For the homeworks, you can work on the homeworks past the due date. It just penalizes you a little bit for being past due. So by now, all of the homework from Chapter 5 is past due. So if you haven't finished it, anything you do on your homework will have a small penalty to it. Now, that's not the entire assignment. That's just the individual questions. So, for example, if you, let's say you had 10 questions. Here, let me write. So on homework, this is only for homework. Come on. Why aren't you working? You're plugged in, you're plugged in, you're plugged in. Okay, why aren't you working? All right, never mind then. Oh, now it's working. So on homework only, let's say that we had one assignment and it had question 1, question 2, question 3, question 4. Let's just say that there were 10 questions. 5, 6, 7, 8, 9, 10 questions. Each question is worth 1 point, so 10 points possible. So let's say that before the due date, somebody got this one right, this one right, this one right, this one wrong, this one right, this one right, this one right. And then this ones they left blank, they didn't do them. So at the moment, they have a score of 1, 2, 3, 4, 5, 6 points. So they have 6 points out of 10. So they have a 60%. 60% on their assignment right now. Okay, and then after due date, they continue to work on it. Then what happens is that if they work on it and they get this question right, it's worth 0.75 points, right? Before, it was worth 1 point. Each one of these was worth 1 point. After the due date, they are still worth 1 point. But this one they redid after the due date, so it's only worth 0.75. And let's say that they decide to do this one, so then they get this one right. It's also worth 0.75 points. And let's say they still leave this one blank, number 8. They still leave it blank, and they still leave this one blank, so they never do it. But they did do 2 other questions. Okay, that means that they now have 1, 1, 1. They still have the original 6 points, plus now they have an additional 1.5 points, which brings it up to 7.5, which brings up their score to a 75%. 75%. Okay, so that's how that works. After the due date, whatever work you do will be penalized a little bit, but not the entire assignment. Anything you have done in the past will continue to receive its full credit. Okay, that's on the homework. On the quiz, there is no such thing as late, right? Once you hit that due date, you will not be allowed to do the quiz again. Okay, did I sufficiently answer your question about the quizzes versus the homework and the due dates?
Yeah, that was good.
Cool. Okay, any other questions on anything? Could be material questions too if you have any problems with any of the quiz questions, homework questions. You guys feel ready for the test? Are there no questions?
So I actually have a question for
Yeah.
section 5.5 with the combinations and I think it's the permutations, like how to tell them apart, basically, of when to use them.
Mm-hmm.
Because I know that for the combinations one is, I'm not sure if like a replacement or no replacement can be done? Because I know that one is a little, well, it's confusing for me.
Okay.
When you can replace and not replace.
So in both cases, let's just first of all begin where they're similar. In both cases, you will have a situation where you have like a pool of items, pool of unique items. They're all special and different. Right? You have this big pool of unique items, right? Like they could be people. Maybe you have 20 students, right? So they're all individual students. They're all different people. Or maybe you have soda brands, right? You have soda companies, Dr. Pepper, Coca-Cola, Pepsi. They're all different and unique items that go into your pool. From your pool, you're going to be selecting one at a time. One at a time. So usually we use the letter N to represent how many items are in your pool. Like maybe there's 20 things in here, maybe there's 75 things in here, whatever. And so usually we use the letter R to represent how many items are going to be selecting. Selecting R items, not supposed to be an R. R items, one at a time, without repetition. Without repetition. Meaning that the same item can never be selected more than once. Once that item has been selected, it has been selected, it is no longer in the pool to be selected again. That's for both of them. Okay? All right. So the place where they differ is that with permutations, we care about the order. Permutations. We care about the order. We care about the order. Right? And then with combinations, we don't care about the order. Combinations, we don't care. We don't care about the order. Okay? So classic examples are selecting people. So let's say that I have a pool of students here. Let's say, just as an example, let's say my N was equal to 5. And so there is 5 students in here. There is a Becky, there is a Tom, there is a Bob, there is an, I don't know, can't think of any names. There's a Sam, there is a Billy. There we go, 5 names. Okay, so there are 5 in my pool. They're all different people. And so I'm going to be selecting them one at a time. So let's say that I want to select them to win prizes. First prize. They get an A in my class. It would be great if this is how I assign grades. Second prize. They get a B. Third prize. They get a C. Right? Just randomly pick them. That's what happens, okay? So now it matters, right? Tom cares about whether he's picked first or picked second or picked third. It makes a difference. So this is a permutation. The order matters. So one example of what could happen is that maybe Billy gets selected first. Billy gets the A. Come on. Billy gets the A. And maybe Sam gets selected second. And maybe Tom gets selected third. Right? Or maybe the order is different. Maybe Sam gets selected first, and then Billy gets selected second, and then maybe Tom is still third. Okay, so here is one possibility. Here's another possibility. Another possibility could be that Tom is first, and then maybe, let's throw in Becky in here, maybe Becky is second. And then Sam is third. Right? Here's another option. Right? So ... So when we use our formula, the formula will tell us how many different options there are. It won't tell us the actual results. It's, the formula is obviously not going to pump out Billy, Sam, Tom, but it will tell you how many of these various things there are, right? Okay, on the other hand, the other thing is combinations. Maybe I want to pick 3 people, and those 3 people have to take a quiz, right? That's it. So in that case, maybe one option could be Billy, Sam, and Tom. So if the thing is that I'm picking people to take a quiz from this group, what does it matter whether you're the first one selected, second one selected, or the third one selected? No matter what, you're being chosen to take a quiz. So what do you care what the order is, right? So in a case like that, order doesn't matter. Good? Good. So you're selecting people one at a time. Repetition's not allowed, so it doesn't make sense for me to pick Billy and then pick Billy again. Like, that doesn't make any sense. I already picked Billy. There is no such thing as 2 Billys, and Billy can't take the same quiz twice. It doesn't make sense. So in this situation, you wouldn't be able to repeat it. There will be cases where you are allowed to repeat it. There are some cases where it does make sense that potentially the same person could be selected more than once. But not in this one. Okay, all right, so then once you decide whether it's a permutation or a combination, then we can follow our formulas for them. So the formula for permutations, we had that permutations of n items choose r, right? So how many are in your pool, how many you're selecting, right? This formula is equal to n factorial divided by n minus r factorial. Good. And then combinations, okay, if you decided it's a combinations question, it's combinations of n items choose r items. And the formula for this guy is n factorial over n minus r factorial. So it's almost identical to that one, except we throw in one extra little twist. There's also an r factorial in the denominator. Good. Otherwise, you could just use your calculator to find it. Once you've set this up, you know it's this, then you can use your calculator and get your result from there. Good. Did I sufficiently answer your question about the difference between permutations and combinations?
Yes, you did. Thank you.
Good. So there's some really classic questions that I love to put on tests involving these guys. Like, for example, there's questions on, what was it? I think it was like songs, something about, there's 20 songs and you only like 7 of them or something like that, and then a random selection is chosen. Those kinds of questions in your homework, they sound familiar, and are there any questions or issues with those questions? Here, let me find it. I really love those questions. Suppose a compact disc CD you purchased has 18 tracks. I know this is an old question. People don't know what a CD is, but let's just assume it was a music device, an ancient music device. Any rate, it has 18 songs on there. After listening to the CD, you decided that you like 6 of the songs. Okay, so you like 6 of them, therefore by default that must mean you don't like the rest, right? So you like 6, you don't like 12 of them. The random feature on your CD player will play each of the 18 songs once in a random order. Find the probability that among the first 5 songs you played, you like 2 of them. B, you like 3 of them. C, you like all of them. Does this sound familiar from homework? I love this kind of a question on a test, so would you like me to go over it to make sure, or are you guys totally okay with it?
Yeah, please go over it.
Please go over it.
Okay, all right, great.
This one was really hard. I don't know if it was just me.
No, it's definitely not you. Statistics
No, it was
is
hard.
really
It was
hard.
really-
Yes, exactly. It is really hard. Okay, so let me make some space over here. This is hard to organize. Come on. Okay. First of all, let me write down information here. So this is from homework on Chapter 5, Section 5. And it's homework number, question number 23. Question number 23 of the questions assigned, which is actually question number 65 in the book, or question number 65 in the book. Okay, so the information we have is that we have 18 total songs. And from the 18, we like 6 of them. 6 we like. And so it didn't say it, didn't spell it out, but that must mean that there are 12 we don't like. Good. Okay, so 6 we like, 12 we don't like. We're going to be, the question says, here we have part A. So suppose that a compact disc you purchased has 18 tracks. After listening to the CD, you decide that you like 6 of the songs, therefore you don't like 12 of them. The random feature on your CD player will play each of the 18 songs once in a random order, so it randomly starts assigning them one at a time, right? And the same song will not be repeated, right? So all 18 songs are in a giant pool, and one at a time is being selected in a random order, but the same song does not get repeated. So find the probability that among the first 5 songs played, you like 2 of them, right? Now, this question, you like 2 of them, does not imply order, right? It's not saying the individual songs. Like, if this was a question that specifically identified you like song number 1, you like song number 7, you like song number 19, I'm sorry, number 18. If it specifically identified which ones you like, and then it asked you, what is the probability that song number 7 that you like comes up first, and then song number 9 that you like comes up second? That would be a case where order matters, because they're specifically asking you which songs and in which order. Whereas here they're just saying you like 2 of them, right? It doesn't say which 2. So the order doesn't matter, but we do want 2 in the first 5 to be songs that you like. Therefore, 3 are going to be songs that you don't like. Okay, so for part A is that you like 2 of them, 2 out of the first songs. So we want to find the probability that amongst the first 5 songs, I'll put among first 5 songs, that you like 2, and therefore don't like 3. Good. Okay, so this is going to be one giant fraction where the denominator is going to be all possible ways in which you can pick 5 songs. So this is going to be combinations of, there are 18 to choose from in your pool, right? So ignoring whether you like them or don't like them, it doesn't matter. 18, and from those 18, you're going to choose 5 of them. So whatever this is the total number of ways in which you can pick 5 out of 18. Good? Okay, but in particular though, we want to figure out the number of ways in which you can choose 2 that you like. So of the ones you like, there are 6 of them, and you want to pick 2. So this is going to represent how many ways there are to pick the 2 out of the 6 that you like, with order doesn't matter. And we're going to multiply that by all the ways in which you choose 3 that you don't like. So out of the 12 possible that you don't like, you want to think about all the ways in which you can select 3 of them. 3 that you don't like. So it's a nice, easy little pattern, actually, because it must be true that this plus this must add up to this. Good. And it must be true that this plus this must add up to this. Good. From this point on, you can just use your calculator to figure it out. This is the hard part, setting it up and knowing what you have to do. But from this point on, let's just use our calculator. Make some space there. And let's go over here. This equals, okay, let's get our calculator going here. Okay, so let's get the denominator going first. So it was 18, and then you go to math, combination, whoops, down, combinations, and 5. There are 8,568 ways in which you can choose 5 out of 18 songs with the order, when the order doesn't matter. And at this point, we don't care about which ones you like and which ones you don't like. This is just any random sampling of 5 songs. Okay, 8,568 ways to do that. Now, of the songs you do like, there were 6 of them. Math, combinations, choose 2. There are 15 ways in which 2 songs that you like can be selected when the order doesn't matter. The order of the songs that you like that is not being specified. On the other hand, of the songs you don't like, 12, math, probability, choose 3. You want to choose 3 that you don't like. There are 220 ways in which 3 songs out of the 12 you don't like can be selected when the order doesn't matter. Good, so now we're going to multiply that numerator and denominator, and we get 15 times 220, and we get that number. Let me write down some of that now. Okay, so this guy was the 15, and this guy is 220. And this guy is the 8,568. So we get 15 times 220 divided by 8,568. Multiplying the numerators, we get 3,330 divided by 8,568. And now when we divide those two, 330 divided 3300 divided by 8,568, we get that decimal, 0.385, let's round to 4 decimal places, 52, 3852. 0.3852, which is approximately 38.52%. There is a 38.52% chance that amongst the first 5 randomly selected songs, you like exactly 2 of them. All right, let me write that sentence down. I wonder if it would be easier for me to put a text box in there. There is a 38.52% chance, right, and that among the first 5 randomly selected songs, you like exactly 2 and dislike dislike 3. This last part is a little, just being extra clear that if you like exactly 2, you must dislike 3, so it's really not really necessary. Whoa, it's really not necessary to do that. Not happy with me. Okay, so there's a 38.52% chance that among the first 5 randomly selected songs, you like exactly 2 and dislike 3. That was part A. I think for part B, they just switched it around. So this is part A. Part B, I think, has the other way around. What if you like 3, but you dislike 2? Right? Part A. You like 3 of them. And then part C is that you like all of them. Oh, so what was it? 31. It says round to 4 decimal places as needed. Did I say 31? No, 38.52. 38.52. 0.3852. Well done. Don't you just love that little green check mark? Find the probability that among the first 5 songs, you like 3 of them. Okay, so now we want to do the same thing for like 3 of them. Zoom out a little bit. It's going to be a very similar pattern, right? Very, very similar to this one. So probability that among the first 5 songs, we like 3 of them, and so therefore we don't like 2. All right, well, again, it's going to be combinations of 18 choose 5, right? This is not taking into consideration which ones you like and which ones you don't like. This is just all the ways in which you can randomly select 5 out of 18 songs when order doesn't matter. And the denominator is going to be the same, 8,568. Good. Now we have combinations of, and now from the ones you like, 6 of them, we want to choose 3 of them. Right? So combinations of 6 choose 3 times, and then we have combinations of the 12 that you don't like, you want to choose 2 of them. Good. So again, we want to use our calculator for this. Let's go back to work. Okay, so clear. We need 6 math combinations. Choose 3. Enter. Get 20. And then 12 math combinations. Choose 2. You get 66. And then we got to multiply those 2 things. So 20 times 66, we're going to get 1320. Good. So we'll end up with 20 times 66, and that's 1320 divided by 8568. Good. And then we divide those 2 things to get our decimal answer. So 1320 divided by 8,568 gets us to 1541. 1541. 0.1541, which is approximately 15.41%. 0.1541. Check answer. Nice work. Okay, let's make sure we put our little sentence down. So, text message, text mode. Okay. There is a 15.41% chance chance that among the first 5 randomly selected songs, selected songs you like exactly 3 and don't like 2. I mean, you could kind of finish it. It's a little redundant, but I would accept either one. So there's a lot of different ways to structure a sentence, right? English is very diverse. So I would accept a wide variety of things as long as you have all the information in there. Don't worry about the structure of the sentence being grammatically correct. This is not an English class. I just want to see the information there. But it is important to write it down in some way to complete your work. Good. Let's do the last one. Part C was the probability that you like all of them. Among the first 5 songs, among the first 5 songs, you like all, which means you like all 5, which means that you don't like 0 of them. Don't like 0, right? So we can just kind of stick to the same pattern of the 6 that you do like, you like 5 of them. And of the 12 you don't like, you choose none of them. Out of 18, choose 5. Good. Okay, so this one's going to be easy. If you have 12 things, how many ways are there for you to pick none of them? There's only one way. Don't pick anything, right? That's it. Don't pick it. Okay, now this one's also pretty easy. Of 6, how many ways are there to choose 5 of them? With order doesn't matter. Just think of it in the reverse. How many different ways are there to not pick one of them? Right? Of all the scenarios out there, there's going to be 6 ways to not pick one of them. Right? So this one should be an easy choice as well, only 6. Or you can use your calculator to confirm your work. So we have from 6, math, combinations, combinations, choose 5, and the answer is 6. Okay, so we're going to have to divide 6 divided by the 8,568, and you see that this is a very small number. Now, when you get this E on here on your calculator, remember that means it's scientific notation. It means that this is 10 to the power of -4. Okay, and we're still going to go out 4 decimal places. So 1, 2, 3, 4. It's 0.028. So this is going to be 7.0028 times 10 to the -4. Okay, so 10 to the -4 means that we grab this decimal value and we move it to the left by 4 spaces. Okay, so when we copy that down here, this is 7.0028, and then we're going to take this decimal place and skip over 1 time, and then we're going to skip over 3 more times, which means we have to introduce zeros. 1, 2, 3 zeros, and that gets me to 1, 2, 3 more spaces. Good. So 4 spaces. Spaces. Come on, computer. Spaces. So that's my new location for my decimal place. So that means that this is the same thing as writing 0.1230 70028. Okay. On the test, I prefer for you to write it, write it this way. Good. Expand out the scientific notation, and then if you want to convert it to a percentage, then we got to go in the other direction. 1, 2 spaces, which means there's only 1 zero. 0.0070028%. So as you can see, there is a very, very small chance this can happen, right? hopefully it's kind of intuitively correct that if we have 18 songs and you only like 6 of them, randomly selecting 5, there's a pretty small chance that you like all 5 of them. But it's not impossible. Okay, so let's see. There is a 0.07028% chance that among the first 5 randomly selected songs, you like all of them. Good. Let's go back over here. Round to 4 decimal places is needed. Okay, so I think that they want you to leave this like this. 0.1230 zeros and then a 7. I think that's what they want. Yes, that's what they want, but wait. But I would prefer if you spell it out this way. Okay, so I want you to go out to 4 decimal places. When you see it in your calculator with scientific notation, just copy it down this way, round off to 4 decimal places, and then just keep them there, so that even though once you move the decimal over, you go past the 4, and you include the extra few numbers over here. Good. Any questions about this problem at all?
Not a question about the problem, but just based off of how you have it formatted, that's how you're going to want us to do our, right?
Yes. So I require you to show your work and justify your answers. So this is a fantastic exam question. If I gave you this as an exam question, you're going to go to that Canvas account, you're going to download your test. You know, one of the questions might be something like this. You don't have to copy down the question on your own paper. You don't have to print it out either. Just start working. So just put, you know, question number 7 on the test or something. Make sure you clearly identify over here. Put a nice big circle of which question number it is. And then show your work. And this is exactly what I'm looking for. Somebody that just gives me this as an answer by itself is not going to get much credit. This is how I grade it. I decide, okay, if they at least wrote down a proper sentence like this is going to be worth 1 point. And then they went over here and they wrote down the actual setup for it. This is worth a lot of, this is more than that. I would say that this is worth maybe 3 points for doing this right. 3 points. Come on, 3 points. And then they showed me what this is, you know, the setup. So maybe I don't require both of these steps. Maybe I would make either worth 1 point. And then the final answer over here, I'll make it worth 1 point as well. 1 point. I don't need that. This is fine. And then a little sentence. Let's make the sentence worth 2 points. Okay. So 1 point for this, 3 points for that, 1 point for this one, 1 point for that thing. What does that make me? That's going to be at 5, 6, right? 8 points possible. 8 points possible. This is what I'm looking for. So as you okay, that's true. Congratulations. You'll get 1 point. 1 out of 8. That's still a very big F. So that's not going to be enough. Okay? You need to show me, you know, get all your points, show all your work. I need complete statistical sentences. A giant P for probability if that's what you're finding. And a description, some sort of description of what that event is. What are you finding the probability of? Doesn't have to be a complete sentence here, but just some sort of little identifier of what it is. And then a setup of where you got your results. If you're doing permutations or combinations, then this is all I need for you to show your work. You don't have to show arithmetic, right? This is not an arithmetic question. So the formula for finding combinations, if you want to do that by hand, then just go do that off to by yourself somewhere. But I don't need to see it, right? So remember, the formula for combinations of 6 choose 2 would be 6 factorial over 2 factorial over 6 minus 2 factorial. If you want to do this by hand and whatever, do that on your own. That's just arithmetic I don't need to see. But I do need to see what the result was, like the 15 and the 220.
I have a question.
Yes.
You mentioned that we can download the test. Can we print it? I like to highlight and circle the stuff that I like. Would that be possible?
Absolutely. I'm just not requiring it because I know some people don't have a printer at home, so I don't want to make it a requirement. But if you want to print it, that's fine.
And then I can send you a picture of my answers from that printout, and maybe can I have an extra sheet of paper?
Well, the problem is that there might not be enough space there to answer, complete your work on there. I'll try and space it out so that there is space for those of you that want to print it. Just try and be neat about it. So that's my only concern. So I'll space it out like I would a normal test in a classroom setting. So there should be enough space there for you to have enough room. So sure, I'll do that.
Thank you.
If you don't, if you don't have enough space, then get a separate piece of paper and continue it or something. Just be neat about your work, so that it's easy for me to tell where your work is for for each individual question.
Okay, thank you.
Okay. Any other questions?
Yeah, one last question. I know that in the problem you have like the combination of how it is. It's fine if I just do like the 15 times the 220 over the 8568, or do I have to show the actual like combination of 6 C2 times? Like,
well,
yeah, I have to show that, or can I just like simplify it to what it really is, which is 15 to 20?
If you just submit this, you'll get 1 point for the answer, 1 point for showing this. So you'll get 2 out of 8 points.
Oh, so I have to like...
I need a probability of something, whatever it is. Probability that amongst the first 7 songs you like 2 of them. Amongst the first 18 songs you like at least 9 of them. Right? I need to know what the question that you're trying to answer is here. So this is worth a point. Then I need to know where the 15 came from. Right? How do I know where you got a 15 from? So this isn't, don't think of this as you submitting a bunch of answers. I already know the answers. I need you to prove to me that you know where the answer comes from. How do I know that you know where you got a 15 from? Right? So you need to prove it to me. And this is enough proof. Okay, I see that you got it from combinations of 6 choose 2. So I do need to see that. Good. Any other questions?
On the test, do you want us to do the decimal, or do you want us to make it and do like a percentage?
I prefer for you to stop there and leave it as a decimal answer. But if you wish to convert it to a percentage, if it makes a little more sense to you or something, that's fine. I will accept it. So if someone, I will accept either one of these, but I prefer that one. But if someone doesn't write this and writes this, I'll be okay with it.
Okay.
And then don't forget about the sentence, right? It's worth a lot of points. So at the end of each question, you should come back and write a complete sentence to describe what you just found, right? There is a blank % chance that 2 cats chosen from a pool of 18 will whatever the question is, right? So tie it back into the question. Good, good, good. Any other questions on this one or anything else from the homework?
No, but I was wondering, since like I just want to know the formatting of how we're going to be doing everything. I was wondering if we can review from chapter 5.4, homework number 14.
Okay, fantastic. Let me go there. Oops. Let's get rid of this thing. From 5.4, you said?
Yes.
Number 14?
Yes.
Fantastic. Number 14.
Just want to make sure that
Yeah.
how we're gonna like the write out of it, just to
Sure.
make sure I know.
Okay, yeah, great question. A bag of 35 tulip bulbs contains 14 red tulip bulbs, 11 yellow bulbs, and 10 purple ones. Okay. Suppose the 2 tulip bulbs are randomly selected without replacement from the bag. Okay, what is the probability that the 2 randomly selected bulbs are both red? Okay, so the notation can vary a little bit, but we want to write down something so that someone can follow the work. So let me write some stuff down. So this is question on homework. This is chapter 5, section 4, question number 14, and then it's number 29 in the book. Question number 29 in book. If you open up your book, question number 29 with that one. Okay, so we have 35 total, and then 14 of them are red, and 11 are yellow, and the rest, which would be 10, are purple. Okay, so part A says, what's the probability when 2 are randomly selected that they're both red? So I would say this is the best way to just note it. Probability that we get a red and a red, comma, red, red. Right. So in this notation, I'm using this to identify that the first selected is red, and then the second one is also red. Good. All right. So this is going to be equal to, and now I'll write more than I expect people to write. So this next little step here might look a little weird. You know what? I think I'm gonna write down more so that it's super clear. Let me write down first is red and second is red. There we go. Let me write it a little bit different. So let's say first is red, followed by second is also red. Come on. It's also red. Okay, so this is going to be equal to the probability that the first is red. Come on. This Zoom thing is killing me. Red times the probability that the second is red. Now, once I've chosen one from this pool, right, there were 14 of them. Once I've chosen one, I've taken away from the pool, the probability that the second one is red is affected by the fact that I took one the first time, right? This is conditional probability. So this is going to be the probability that the second one is red given that the first one was red. Is that clear? That the second one, once you go back to the pool and you randomly pick another tulip, this probability is going to be different. It's going to be affected by the fact that the first one was red. Good. So the first one being red is equal to 14 out of 35. Right? There's 14 red ones out of a total of 35 times the probability that the second one is red. Now, how does this get affected? The second one is red. Well, first of all, once you've already taken one tulip, there's no longer 35 options. There's only 34. And of those 34, there are 13 red ones that remain. So the multiplication of these two fractions will give you your answer. Good. So this will be equal to, let's get our calculator. It's 13 times 14 divided by 35 times 34. This over here. So I need 14 times 13 gives me that number. And then 35 times 34 gives me that number. And then I need to divide those two. 182 divided by 1190, like that. So now coming back over here, I know that this is going to be a division of, why is this? This is going to be a division of 182 divided by 1190, which is equal to 0.1529. About a 15.29% chance. Good. So then we get a nice little sentence going. There is a 15.29% chance that the first two randomly selected red. Oh. All right. So what is it? It's 1529. Round to 3 decimal places. 0.1529, 1529. But then it says round to 3 decimal places, so the computer wants you to go to 3. Check answer. Fantastic. All right, let's do part B. What is the probability that the first bulb selected is red and the second one is yellow? First red, then yellow. Part B. What is the probability that the first one is red and the second is yellow? Okay, so that's equal to the probability that the first is red times the probability that the second is yellow. This Zoom thing is killing my computer. Is yellow, given that the first was red. Okay, so the probability that the first one is red stays the same as before. There was a total of 14 red ones, 11 yellow, 10 purple. So the first probability that it's red is still going to be 14 out of 35. But the second probability, that's going to be a little bit different now. So the probability that the second one is yellow, given that the first one was red, just means that all 11 yellow ones are still in the pool. None of them have been selected. The first one selected was a red one, right? So when you go back into your pool the second time around, there's now 34 tulip bulbs in there. But the first one selected was a red one, so now in this 34 there are now 13 red ones. But you don't care about red, you want to try and pick a yellow one, of which there are 11. So this fraction will tell you your answer. Okay, so we need to multiply 11 times 14, and the denominator is actually going to stay the same, 34 times 35. We're still going to end up with 1190. We just have to multiply 14 times 11, so 154, and then 154 gets divided by 1190, and that's our answer, 1294. You get 0.1294. 1294. .1294. Okay, round to 3 decimal places. So again, we go back to there, so we leave it there. Okay, don't forget your sentence. And you know, the sentence, you basically go back to the question and repeat what they asked you and just insert the answer. What is the probability that the first bulb selected is red and the second one is yellow? So our sentence should be, there is a 12.9% chance, or probability, there's a 12.9% probability that the first bulb selected is red and the second yellow. Good. So, you know, the sentence doesn't have to be a big deal. You just go back and mimic what it says right there. There is a 12.94% probability that the first bulb selected is red and the second is yellow. Good. Second is yellow. Okay, and then back to grading. This is a fantastic exam question. Something like this definitely be on your test. So as I'm grading this, I'm looking for confirmation of things, right? You can't just give me a 14/35 without any justification at all. How do I know where that number came from, right? Imagine that you're presenting your work to someone that has no background in math or statistics, and you're proving to me that this is the thing, right? You need to confirm it to me. So as I'm grading this, I would say I need a proper probability statement. So this is worth 1 point. I need some evidence of where you got these numbers from. So this or something like it would be good. And this is really the heart of the question. So I'd say this is worth 3 points. Again, like I said, there's different ways of noting it and writing it down. So this guy I would make worth 2 points, maybe. And then either one of these, well, either one. And then finally 1 point for that. And then I like my sentence, so let's make that 2 points. So this question would be worth 1 point, 4 points, 6 points, 7 points. So here we go, 9 points. So this is how I would grade it. So this is a question worth 9 points. Okay. any questions on this? No more questions on this? No? Just to really drive the point, let me answer another one that wasn't necessarily asked, but just to really highlight the point. What's the probability that the first one is red? Well, we've been doing red a lot, huh? Let's do a different one. First one is purple. The second is yellow. And third is purple. Come on. Purple. And the fourth is red. Good. All right, so this is going to be pretty ugly here. So it's going to be equal to the probability that the first one, let me reimagine this because it's going to get really ugly. I'm going to say the first equals purple, the second equals yellow, the third equals purple, and the fourth equals red. Otherwise, that notation is going to get a little ugly here. So this is going to be equal to the first probability that the first one is equal to purple. Okay. Times the probability that the second one equals yellow. Come on, zoom. Yellow. Given that the first one was purple. Times the probability that the third one equals purple, given that the first one was purple and the second one was yellow. Times the probability that the fourth one equals red, given that we know that the first one was purple and we know that the second one was yellow and we know that the third one was purple. Okay, so now we can find each one of these individually, and the actual work is not that bad. What's the probability that the first one selected is purple? Let me write down our totals over here one more time so it's right over this. So we had 35 total bolts. There were 14 red ones. It was 11 yellow. And there was 10 purple to begin with, right? Okay, the probability that the first one is purple is going to be 10 out of 35. Good, done. Times the probability that the second one is yellow, given that the first one is purple. So when I'm revisiting my pool at this point, one of these guys is gone, right? Now there's only 9 left because I picked one purple one. So the second time I come back around, there isn't 35 of them total, there's 34 of them total. Okay. So the probability...
We're still without a replacement, right? Sorry about that.
Correct, this is without replacement. Good point to highlight, right? All of these are without replacement. Okay, so then the second one, probably the second one is yellow, is going to be equal to 11. Oops. Is going to be equal to 11 out of 34 because there's 11 yellows. Good. So that's this guy. Probability that it is yellow, given that the first one was purple. And now when we go to the third one, okay, so now probably the third one is purple, given that the first one was purple and the second one was yellow. So now when you revisit your pool this third time around, you also have to take into consideration that you've already selected one of the yellow ones. So now there's only 10 yellows in the pool. And that means that there's a total of 33 of them, from which you're going to be picking. So what's the probability that that third one is a purple? Well, 9. There's 9 of them in there. So it'll be 9 out of 33. And finally, the last one you visit here is this last one. What's the probability that the fourth one is a red one? Well, you haven't even touched any of the red. There's still 14 red. However, you have to take into consideration that now you've also selected one more of these purples. So there's only 8 purples left, 10 yellows, 14 reds, which means that there's a total of 32 left in the pool. So this last probability is going to be 14 red out of 32 possible. Good. So you multiply all that together and that'll give you your answer. Now we can find these individually. 10 divided by 35, get a decimal. 11 divided by 34, get a decimal. We could do that, or we can just combine them all into one big happy fraction. Remember that when we multiply fractions, we do not need a common denominator. So it's just a matter of multiplying all these things together. Good. All right, so let's do that in our calculator. I get parentheses 10 times 11 times 9 times 14 divided by parentheses 35 times 34 times 33 times 32. Close parentheses. And that does everything all at once, and it gives me an answer of 0.01103. Oops. Okay. So 1.103%. A pretty small chance that you get this specific order. First one was purple, second one yellow, third one was purple, fourth one was red. Good. Questions? Okay, so if you get stuck on the notation, then that's okay. I need something, right? If you're not sure, then just write out sentences, right? I just need justifications of where these numbers come from. If you get a little stuck on the on the structure of how to write this down, then just write down a little sentence. That's fine. Okay, I just need some sort of justification. Where did those numbers come from? Any other questions? No? Good? Done? Set? No questions? No questions? Okay, if there's no more questions, then this would be a good place to stop. Okay, so good place to stop then. No more questions?
I had a quick question for the test. Are we allowed to use notes with that? Like, can we write out a sheet of notes, or
Yes.
because I have like a whole notebook with notes that we've taken in class? Can I also use that?
You can use any notes you want. You can use the book. You can use any reference you want, as long as on what you turn in, you show all your work. This is what I'm looking for. All spelled out, all the work to justify each question. But yes, you can use the book. You can use your online homework. You can go back to Course Compass, and go through your work, previous homework assignments and stuff like that, and work through that. So you can use all those resources. Of course, you can use your calculator as well. There's also online calculators if you don't have a calculator yourself. So you can use any of those references, but at the end of the day, when you turn in your work, I need you to justify each question with detailed work. Handwritten on your own, by your own hand. I also don't want any kind of computer printout or anything.
Well, thank you.
You're welcome. Any other questions? We're good? So everyone's going to ace the test tomorrow, right?
I don't know about ACE, but okay.
All right. Okay, well then I will see you tomorrow then. Have a good day.